Hi there, my name is John Quiz Bouye, and this is my Cap 1 pathways our bodies use to produce ATP from the complete breakdown of one molecule of glucose and one molecule of fat. Within this diagram, we will be stating the proper pathways, as I stated, of one molecule of glucose and one molecule of fat by using this diagram from my exercise physiology book, Nutrition, Energy, and Human Performance by Mark Ardle et al. 2017. So, to begin this process, it first must go through glycolysis. Glycolysis needs 10 enzymatic reactions in order for it to break down glucose into pyruvate, which then is converted into lactic acid in phase 1. Phase 1 is considered anaerobic, therefore not needing oxygen, and the end product is lactate. Phase 2 is considered aerobic, and that is when it uses oxygen to properly pass from pyruvate to acetyl-CoA, which I will get into further, and then into the Krebs cycle to produce ATP. So the rapid glycolysis is considered anaerobic, and the slow glycolysis or aerobic glycolysis, which is considered slow, is aerobic. So after that, stage 2, pyruvate to acetyl-CoA. The process of pyruvate to acetyl-CoA, each acetyl-CoA enters the Krebs cycle and releases 2 carbons and 4 pairs of hydrogens. But before that, this from pyruvate to acetyl-CoA, pyruvate oxidation must happen to form NADH, 2 carbons that break off to form acetyl-CoA, and some of the carbons form carbon dioxide. So, stage 3 is the Krebs cycle. As I stated, pyruvate enter the Krebs cycle and release 2 carbons and 4 pairs of hydrogens. So after acetyl-CoA, it joins a compound called axial acetate, and it must go through a number of steps and channels which are involved in the Krebs cycle. These steps include citrate, cis-acetate, isocitrate, oxalosuccinate, ketoglutarate, succinyl CoA, succinate, fumarate, malate, and back into oxaloacetate and over again. So, since glycolysis produces 2 pyruvate molecules, the Krebs cycle must happen twice. So, as I stated, these steps happen and these steps produce NADH, 1 NADH, and then also note 1 NADH equals 3 ATP. And then in the Krebs cycle, there are 3 NADHs, so therefore there are 9 ATPs from the NADH that are produced. Next is FADH2. Only 1 FADH is produced in the cycle, and it produces 2 ATP. Next is GTP. GTP only produces 1 ATP. There's only 1 GTP within the Krebs cycle. In these Krebs cycles, 9 ATPs are produced, and since it has to happen twice, 18 ATPs are produced. The next step is oxidative phosphorylation. So during this process is when electrons are being passed on and oxygen is being reduced. And also from this, even more hydrogen protons are being released to create energy, and that energy is then produced into ATP. And by this, I mean that it goes the compounds go through a protein gradient, which are then releasing the hydrogen protons and releasing some of the energy to produce that ATP. So from the total ATP of one molecule glucose, the production of ATP from substrate level phosphorylation and glycolytic pathway leading into the Krebs cycle results in 2 ATPs. A total of 10 NADH molecules are produced leading into the electron transport chain, and this is from 2 of the glycolysis, 2 from the process of pyruvate to acetyl-CoA, and 6 from the Krebs cycle. So as I stated earlier, I mentioned all the numbers of the compounds in it. So in total, there are 30 2 ATPs produced from 1 molecule of glucose, according to Kenny et al. So, as for 1 molecule of fat into energy, these are the diagrams we'll be using. They are also from the text. So stage 1 is break down triglycerides into glycerol and free fatty acids. Stage 2, transport of free fatty acids into blood. Stage 3, uptake free fatty acids in the blood. Stage 4, prepare the free fatty acids for catabolism. Stage 5, activated fatty acids then enter muscle mitochondria. Stage 6, break down fatty acids into acetyl-CoA by beta oxidation, which then produces NADH as well as FADH2. This causes splitting of the carbons, also which joins coenzymes. Beta oxidation continues to happen until the full breakdown of fatty acid. Stage 7 is the Krebs cycle. So, as I stated, 1 triglyceride is broken down into glycerol and 3 fatty acids. But glycerol is only accepted when it is considered the term 3-phosphorylglycosyloride. Phosphorylglycosyloride. Yep. Saccharide. This is then broken down to pyruvate by substrate phosphorylation, to form ATP, as well as positive hydrogen atoms pass on to NAD+, and the Krebs cycle to oxidize pyruvate. So from this, the breakdown of glycerol is equivalent to 19 ATP. Along with that, as I stated, there are 3 fatty acids. These 3 fatty acids, we'll go back to the diagram. These 3 fatty acids then go to beta oxidation. From beta oxidation, it then goes back into, it joins the 2 carbon acyl groups and the COA back to acetyl-CoA, which then go through the Krebs cycle, as well as they go through the electron transport chain. From this, in total, a total of 441 molecules that are converted from ADP to ATP are produced. Along with that, the 19 from glycerol make an equivalent 460 ATP. So, how these pathways interact across intensity and duration. So, since glucose is broken down faster and quickly and is more of a first resource compared to fat, fat takes a longer period of time to go through that process. Glucose is therefore the first source of energy within our body. That's why carbs are also the first source of energy within our body. And so most of the time when it's used during either rapid movements, high intensities, or light or moderate exercise. When considering fat, fat is mainly used when it's a long duration of exercise, and that's because of its slow breakdown and slow metabolism. Some of the limiting factors for glycolysis, the limiting factor is NAD+. Since when it is unavailable, the other half of glycolysis is slow and tends to shut down, as well as oxygen has been known to be an inhibitor, according to the text. And for oxidative phosphorylation, lack of oxygen is a limiting factor as well. For beta oxidation, oxygen is also another limiting factor. Without beta oxidation, the process won't continue because it is an aerobic process. In conclusion, based on the pathways and the energy provided from the glucose or fat, this applies to the real world by informing that our bodies use certain systems based on select type of demand our body recognizes throughout our central nervous system. And by this I mean, if it's a rapid movement, our body knows to, look for any types of carbs or glucose as our first source of fuel. And if it's a long duration and our glycogen stores have been depleted, it knows to, use that fat that has been stored in your body, and that fat that's been stored in your body as an energy source. Thank you for watching my presentation. Goodbye.